Yes. So again, coming to the second PPT. So in earlier first PPT, I explained about the what is the importance of FEM and why we want to study. And okay, so and I given also the introduction to syllabus. Okay, so here in this PPT, I'm going to tell you about the very important question. This, okay, what are the basic steps involved in FEM? Okay, to solve the numerical problems. Okay, so here we are going to take any FEM problems. Okay, these are the 6 steps you are going to use to solve the numerical problems. Okay, so I told you what you mean by finite element method. So it is a numerical method. Okay, so first we are going to divide the given element into a small pieces or region. Okay, that region we are going to call as the element. Okay, so here it is a numerical. Okay, it is a numerical method to solve the engineering complex problem. Okay, that is complex. Even sometimes what the physics problems. Okay, complex geometries. Okay, those problems related to what, the material, loading, boundary condition. Okay, if you solve very simple, then this subject is called okay, if you solve by using this tool, that is what, finite element method. Okay, just to understand that so finite element method is a numerical method to solve a engineering complex problem subject to a what, the material, boundary condition, loading. Okay, is called as finite element method. Otherwise it is a what, it is a numerical technique. Okay, which is used to perform the finite element analysis for a given physical phenomenon, that is given complex problem with the help of software called as what, in our lab we are going to use ANSYS. Okay, it is the definition of finite element method. Okay, now the question is, this question is very important. Okay, every semester this question may ask you in the university. Okay, that is what, explain what is define the FEM and what are the basic steps involved in FEM. Okay, that is how we are going to solve the numerical problems with the help of this FEM tool. Okay, so here there are 6 steps are there to solve a numerical method of the finite element method. Okay, first one is what, the discretization of the given body or element or structure or problem. Okay, this is the first step of finite element method. Okay, discretization is the first step, and the second one is selection of a displacement function. Okay, and the third step is derivation of a element stiffness matrix. Okay, and the fourth one is what, the assemble of algebraic equation for the overall discretized body. Okay, with the help of some formulas. Okay, and apply the boundary condition, and finally you are going to calculate what, the stress, strain, displacement and reaction. Okay, so in the FEM subject almost 90% is almost all the problems you are going to calculate only these 4 factors. Okay, stress, that is sigma, strain, displacement, I am going to use here notation U, and reaction, that is what, capital R, reaction is the support or point. Okay, so these are the different 6 steps involved in finite element method. Let me understand one by one. Okay, what do you mean by discretization process, and what do you mean by selection of displacement model function, and derivation of it is shortly called as what, ESM. Okay, capital ESM. ESM means what, element stiffness matrix. It is denoted by matrix K. Okay, and assemble of algebraic equation for the overall discretization body, that is the 4th step. Okay, with the help of formula. And fifth thing, apply boundary condition to calculate what, the last step, that is stress, strain, displacement, reaction. Okay, let me understand one by one now. Okay, so here the first step. Okay, the discretization means what, to divide the given element. Okay, to divide the given element into small pieces in the ANSYS. Okay, that is step number 1. I hope you understand this discretization means. Discretization means to divide the given element. Okay, the first step of finite element method is to divide the given element into a small region are called as element. Okay, let me understand this diagram. Okay, so this is a very big sheet. Okay, let us assume that this is a plain sheet. Okay, our aim is to find the stress for the given plate. Okay, the first step is what, to divide the element. Okay, so we have to divide the divide the given plate into small pieces. Okay, this dividing fashion, this dividing structure may be any type, either triangular or what, rectangular, whatever that point level. Okay, whatever that. Okay, depending upon the given customer, that is what, given person. Okay, here I am going to divide this small pieces into a small element. Here we are going to get what, the triangle. We got the shape. Okay, we divided all element in the form of what, triangle. Okay, so here like the triangle element. Okay, this is a large big plate. So this is a large big plate, we are going to divide that into a small pieces. Okay, so here this first step we are going to calculate. Okay, the same triangle I drawn here. Okay, this side. Okay, so each node, how many degree of freedom will be there. Okay, for the triangle is a 2D element. Okay, here how many elements will be there for the triangle, 1 2 3. Okay, at each node 2 degree of freedom means each node having a 2 degree of freedom. Okay, 2D element means 2 degree of freedom. Okay, one is along x, one more is along y. So u I denoted as u1 and y is denoted as v1. Okay, so similarly u2 v2, u3 v3. Okay, so the from this we are going to divide the element and which type of element you are getting and how many degree of freedom will be there for each node, that we are going to understand by using step number 1, that is discretization of the given body. Okay, this is about the first step. I hope you understand. Okay, second step is for selection of a displacement model. Okay, once if you divide the given element, okay, the second step is to select the model. Okay, so whether it is a which type of element or how, what is the order of the function, the material, the model selected should be whether it is a specific magnitude or what. Okay, all those things you have to observe in the second step, that is what selection of displacement model with the help of two, by using two technique, that is what polynomial function and trigonometry function. But present day the polynomial functions are widely used. Okay, so we are going to solve by using this polynomial function, not for this trigonometry function. Okay, so if you solve one numerical problem means you will understand. Okay, so second step is what, to understand which type of element, okay, and the order of the function, and the model selection should be a specific magnitude or what. Okay, the displacement model selected should be satisfy the some certain condition. Okay, that is called as convergence criteria. Okay, all these three factors should be known by using the second step. Okay, so first step is what, to divide the given element. Second step is what, to understand which type of the element it is or how many degree of freedom will be there, that using polynomial function. Okay, we are going to use this polynomial function, not trigonometry function. Okay, so this is little complicated as compared to this, so hence we are going to use this. Okay, this is about the second step. Okay, third step is what, here the third step is what, derivation for element stiffness matrix. Okay, to calculate the ESM, it is shortly called as ESM. Okay, that is what, element stiffness matrix. Okay, once if you divide the given element, you have to calculate the each element of the derivation of element stiffness matrix. Okay, each element you have to calculate the stiffness, what is the stiffness of that particular element. Okay, with the help of formula called as what, k into u is equal to f. You have to write in this fashion only. Okay, matrix k is equal to this capital D, u and f. Okay, where k stands for what, element stiffness matrix, and u stands for what, the nodal displacement. Okay, in different textbook different notations are using the displacement, but I am using u vz displacement. Okay, so f is what, nodal force, already shortly called as force. Okay, I hope you understand this. Okay, this again k is formula is different, u formula is different, f formula is different. Okay, while solving a problem you are going to solve that. Okay, so okay, just to remember that once if you divide the element, you have to calculate the element stiffness matrix for each element, that you understand by using this formula, that is ku is equal to f. This is the third step. Okay, now coming to the fourth step, so assemble the algebraic equation of the overall discretized body. Okay, so here what you are calculated element stiffness matrix for each element, you have to combine all those things. That is what the fourth step, that is assemble of algebraic equation of the overall discretized body. That is each element you combine, you are going to get a global stiffness matrix. Okay, so here this method involves this determination, that is what, calculating the global stiffness matrix and global force vector with the help of f is equal to ku, same formula. Okay, where k is equal to global force vector. Okay, and where k is equal to what, global stiffness matrix, f is equal to global force vector, and u is equal to nodal displacement. Okay, so here the fourth step is what, to assemble all the element stiffness matrix which gives the global stiffness matrix. Okay, so fifth step is what, if you want to calculate the stress strain of a particular given plate, then you need to use two techniques, and then you apply the boundary condition. Okay, that to find the nodal displacement we have to apply the approximate boundary condition or apply to the global equation. Okay, what to calculate the global stiffness equation, you have to apply the some boundary condition using two technique, one is elimination method and one more is penalty method. Okay, so elimination method means we are going to eliminate to rearrange that particular problem, and penalty method we are going to add some values to the particular matrix and you rearrange that, you are going to get the solution. Okay, these are the two different method. Okay, we are going to solve penalty method problem also, elimination method problem also. Okay, so once if you apply the boundary condition, then finally you are going to get what, calculate the stress strain reaction by using these two methods. Okay, already you know the stress formula, stress is equal to what, force by unit area, strain also what, and reaction force, what is the using, what is the reaction. Okay, with the help of formula you are going to calculate what the stress strain reaction of the given problem. Okay, so like that these are the some basic different, that is what, basic steps involved in finite element method. Okay, this diagram also I shown in the chart. Okay, so first one is what, selection of the geometry model, that is what, selection, first to select the model that is a problem and discretize the problem, that is divided into small pieces. Okay, selection of the approximate shape function. okay, have to choose the polynomial function, okay. And next one is develop the finite element equation, that is calculate the element stiffness matrix. Again, next one is calculate the assemble element stiffness matrix, that is a global stiffness matrix. Then you apply the boundary condition, then finally you are going to get the result, okay. Like this, this is the flow chart will be there to explain the basic steps involved in FEM, okay. Just to remember from this, okay, what are the basic 6 steps involved means what? These are the 6 steps. First one is discretization, means divide the given element. Second one is the selection of displacement model, that is to understand the which type of element order and selection of the model is a specific or what, that you have to understand what in the second step. The third one is what? Derivation of element stiffness matrix, okay. Each divided element you need to calculate the ESM, okay. Fourth step is what? Assemble the all the overall discretization body, that is global stiffness matrix you are going to get, and then finally apply the boundary condition, you are going to get what? Stress strain displacement reaction of the given particular problem. These are the basic 6 steps involved in finite element method to solve any numerical problems of finite element method, okay. So you have to this is very important, okay. In every what, in every year, that is what, in every year this question may ask you what do you mean by finite element method and what are the basic steps involved in finite element method, explain it, okay. You have to explain these 3 things, okay. Finite element method, it is a finite element method is a numerical technique which is used to perform the finite element analysis of any given complex problem, or the finite element method is a numerical method for solving the problems of engineering and mathematical complex those problems subject to what? Some condition, that is what? Some boundary condition, that what? Material loading boundary condition, okay, is called as finite element method, okay. So I hope you understand these are the 6 basic steps involved in finite element method, okay. Thank you.